And the 4 theorems that you guys came up with yesterday involved, if you have parallel lines, then this thing is true, right? Each one of those started with the assumption that you had parallel lines. And if you knew you had parallel lines, then these 2 angles were congruent. Or if you had parallel lines, then these 2 angles were supplementary. All 4 of those theorems did something like that, okay? That was the flow of it, from parallel to some other conclusion that you made. Today, our goal is to show that the lines are parallel. So our goal is to go in the opposite direction of that. So if I know these 2 angles are congruent, then I know the lines are parallel. Or if I know these 2 angles are supplementary, then I know the angles or the lines are parallel. Okay? So yesterday, parallel was the hypothesis. The angles being congruent or supplementary was the conclusion. Today, the angles being congruent or supplementary is the hypothesis, and the lines being parallel is the conclusion. Okay? So what is the conclusion swap? What's that called? It's a converse. Okay? So there are 4 theorems we're going to look at today, which are actually just the converses of the ones we looked at yesterday. Okay? The idea, the relationship is still the same. It's just the flow of the logic goes the other way. Okay? So I'm just going to jot those down for you here real quick. And then these are ones that can go into your theorem sheet as well. But in your theorem sheet, please make sure that you're doing like the full actual theorem. I'm just going to abbreviate things here for you. So you have theorem 3.6. And it basically states this. If you have alternate interior angles that are congruent, then the lines are parallel. Okay? Like I said, converse, other way. Okay? Yesterday you had theorem 3.1, which said, if you have parallel lines, then the alternate interior angles are congruent. Well, the opposite is true too. Theorem 3.7. If alternate exterior angles are congruent, parallel lines. Again, that's the converse of 3.2. Theorem 3.2 said, if you have parallel lines, then the alternate exteriors are congruent. Well, the converse of that is also true. If you know the alternate exteriors are congruent, then you have to have parallel lines. 3.8. All right, this one says, if consecutive interior angles are supplementary, then we have parallel lines. Oh, oops, I skipped over the first one. 3.5. I'll squeeze that in up at the top here. We forget about corresponding angles. What did we know about corresponding angles and parallel lines? What has to be true about them? What has to be true about corresponding angles if we have parallel lines? They're congruent. Right. So, converse of that. If corresponding angles are congruent, that's another way to show parallel lines. So yeah, we're doing proofs today, but the proofs aren't real difficult because we have these guys to work with. Okay? if we want to show two lines are parallel, if you have some kind of proof where it says this and this is congruent, so prove that these lines are parallel, it's usually just 1 or 2 steps in your proof and you're done. Well, not 1, but 2, 3, maybe 4, and you're done. So they're going to be pretty short proofs by the time we're done with them here. Let's do an example of that. We'll make a proof here. Okay, so there's our picture we're going to use. We got lines L and M and line T, and then there's angles 1 and 2. So our given is that the measure of angle 1 plus the measure of angle 2 equals 180 degrees, and we want to prove that L is parallel to M. All right, so we'll do this one a 2-column proof. So first, our given, right? Measure of angle 1 plus measure of angle 2 equals 180. Given. Okay, so think about those 4 theorems we just wrote up at the top. Which one of those 4 do you suppose we're going to use in this proof? Yes, sir. You got it, right? Because it says, if we know that the consecutive interior angles are supplementary, then the lines have to be parallel. Okay, do we know that the consecutive interior angles are supplementary? Yes, we do, right? How do we know that? That's what I just said, right? Measure of angle 1 plus measure of angle 2 equals 180. Now, if I'm going to use this theorem, though, 3.8, I need to have a statement somewhere that says this angle and this angle are supplementary. Technically, I don't have that yet, but I can very easily get there, right? I can just make that my next step because I've shown that. So step number 2, angle 1 and angle 2 are supplementary. And how do I know that 1 and 2 are supplementary? Yeah. Definition of supplementary, yep. Because this is what it means to be supplementary, so use the definition. Okay, so angle 1 and angle 2 are supplementary. I know angle 1 and angle 2 are consecutive interior angles based on the picture, so I can go right to L is parallel to M. And how do I know L is parallel to M? Theorem 3.8. Okay, it's that kind of stuff. All right, see if we can do another one. Said they're not going to be real long. All right, got a little bit more going on this one. at lines L, M, N, and then there's the transversal T, and angles 1, 2, and 3. So my given for this one is going to be angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, and I want to prove that line L is parallel to line N. So while we're writing this stuff down, see if you can kind of see the roadmap in your head. So if we want to show that L is parallel to N, what do we really need to know about the picture? How can we put our proof together to do that? Okay. So, if I want L to be parallel to N, what has to be true in this picture? Yeah? Oh, yeah, go ahead. So, everybody else. If I want L and N to be parallel, what has to be true about what's in my picture there? Yeah.
That angle 1 has to be congruent to angle 3.
Exactly. Angle 1 is going to need to be congruent to angle 3, right? And then we can say that those lines are parallel. Now, do I have that technically in my given?
No.
Not precisely, but I can get there fairly easily, right? Yeah? You had your hand up, so yes? Oh, good. Go ahead. That's kind of what I was going for. So, yeah. Based on the given information, it's true, right? What we want. So angle 1 is congruent to angle 3. Now, why is that? Somebody who has not spoken yet. Yes. That's a transitive property. Good. Now, be careful if you were going to say substitution. Substitution wouldn't work in this one. Substitution only works when you have an equation. And these are congruent, not equal. So you can't do that. Okay, but now, we got what we want, right? 1's congruent to 3. So, what tells me that the lines are parallel then? Because I can get to that in my third step here now. Yeah? Theorem 3.5, right? Corresponding angles are congruent, means we have parallel lines. 1 and 3 are corresponding angles for L and N. They're parallel. Theorem 3.5. Okay, you guys can do these proofs. They're not meant to be difficult. So part of what you're going to be doing is putting some proofs together, showing some of that stuff. The thing that you'll be working on is just looking at a picture, looking at what the measurements are in the picture, and then trying to determine yes or no, are the lines parallel, just based on the measurements. And you guys have done a bit of that already.